So, let's start our lecture today. So, um, uh, last time I think I get stuck with one 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 scenario here. So namely, I have that. Uh, so so basically for m equal to 1, so uh, uh, so so last time uh, we are assuming that uh, we have a1 is equal to k times a2, where so k is like a positive integer, and then for the remainder, so when we have so first we into after fixing m equal to 1, we have the remainder. We have the remainder as so we sum over I from 1 to infinity of summation n from ik plus 1 to I plus 1 k minus 1, where we have the summand is equal to n squared minus k squared over 4 times n squared a2 plus k squared a2 squared. And then, so this gives us the remainder for the case where m equal to 1. So I think, let me check. So when we have so m equal to 1 is km. Okay. so I think I may be making a mistake somewhere. So this is just so let me double check to make sure. So in 2, so we fix m equal to 1. So we have the sum from n equal to k plus 1. So yeah, let me draw like the picture here. So you can have a y and you have an x, and then so this is exactly the points where n equal to 1 and m equal to 1, and we have the lattices, and also we have the k like that, and then yeah, for this case like x equal to ky, and then so this is the remainder that I calculated for m equal to 1, and then so this is the region 1, this is the region 2. I think there might be a problem here because so in 1 also we are fixing n equal to 1, and we have the sum as summation m equal to 1 to infinity of 1 minus k square m square over 4 times a2 plus k square m square a2 square. So and also in 2, right? So this is just like some check. And also in 2, so similarly, when we are fixing m equal to 1, so we have so we will get summation. So this n star at equal to k plus 1 to infinity n square minus k square over 4 n square a2 plus k square a2 square. So I think so here this m star at 1, right? So this one should be the km square, and then so km square should be corresponds to this n, right? So I think this m equal to 1 is now being cancelled out, So it should start at m equal to 2. Right? So so this n start, so the things that cancel out should be so cancellation happens at exactly where n is equal to start at 2, right? So 2k, 3k, 4k, etc. And wait, n equal to 1. Wait, m equal to 1. Okay, it should be n equal to k. Okay, so okay, I know where I made the mistake. Okay, I know where the mistake comes from. So yeah, it should correspond to n equal to k. So it should be k squared here. And then this corresponds to m equal to 1. Okay. So, okay. Yeah. But still, in this case, okay. So in this case, this m doesn't start at 1, right? So this m starts at 2. Okay. So yeah. So here, I think everything makes sense now. So, yes. So here, the calculation happens exactly at n equal to like multiple copies of k, right? And then when this n equal to multiple copies of k, this n squared becomes some constant times k squared, okay? And then which corresponds to the same thing as this guy, and also this guy, and the same thing as here. So they cancel out. Wait. No. So sorry. So n equal to k. This one should be k squared a2. Okay, my bad. So k squared a2. So therefore, so yeah. So these correspond to this term, and this correspond to this term. Okay, and also this k squared cancel out with this one. Yeah. So everything cancelled out very nicely, and then so here what we are trying to do is that we are trying to sort out the so we are trying to sort out the using some I think it should be the same, right? So I think it must be this one. So when I from 1 is start at n start at k plus 1, and then I equal to 1, it ends at 2k minus 1, missing 2k, and then I equal to 2 is at 2k plus 1. Yeah. So I think there should be no problem for this one. So maybe let's see in general. Okay. So in general, if let's fix it at m. Okay. So let's fixing m arbitrary. And then so this n should be, so in this case, if m is arbitrary, then it would be so for example, I think it should be mk, right? And here it should also be mk squared, so plus squared. Let me double check this one. Yes. Yeah. And also, we have, so what is this one? So here, I want to fix which one do you want to fix? So I think this n should be exactly equal to mk, right? So n should be now n equal to mk. Okay. So in this case, this n also has the sequence like k. I'm just keeping a note by myself because I think so. I think there will be something left with this scenario. So and also we have so when n equal to mk, so we have so this one is so for the m, right? So the m start where? So remember that. So this m originally is the start at. So originally this m should start with the lower limit, right? Sorry, the integer part of the fraction plus 1. So now it's equal to m, so it should be start m plus 1. So right, so that is j here. And so this is j squared. And then, so this is mk squared. And then, so this is 4 times mk squared a2. And then, so this guy is j squared. And then, so so here the cancellation happens at exactly hold on 1 second. So here, this n should be equal to mk plus 1, right? Okay. So the cancellation happens at exactly m plus 1k, I think. Yeah, I think that should be the same. So why am I doubt? So it should be because the j start at m plus 1. So and then so this is m plus 1. Yeah, so it should be m plus 1k at the first one. Yes, and then we have the m plus 2k and yeah, so it should be okay, yeah, so this is true. So m plus 3k. So if I were write you a formula, so that would be the remainder. So the remainder would be m arbitrary case. It will be, so we are taking the sum of which one? So it should start at wait. I need an I here, right? Oh, I think the I is the thing that I made a mistake. So here, let's use an I here, and then let me oh, I think I make a mistake here the last time. So here, this I start from where? Well, I start at 1. So where do you want to start? I want to start at so this when I equal to 1, this gives you exactly the first coefficient, right? So so maybe I'll use I think it should be m minus 1 plus I times k plus 1. So yeah, so this is n equal to m minus 1 plus I, because when I equal to 1, I want to start at the mk position and then plus 1. Yeah, I think this is the part where I messed up last time, because last time I used So I think this is the place where I messed up last time. Yeah, because okay. So this one, and then where does it end? So it ends at it should be so it should be m plus I k minus 1. So when you plug in n I equal to 1, so it should be mk, right? Wait, no. Oh yeah. So when you plug in m equal to 1, it should be m plus 1k minus 1, which is exactly this number minus 1. Yes, it's okay. Okay. And then we have that, so summand will keep it the same, right? So we have the n squared minus mk squared over 4. Let's take the h2 out, and then we have the n squared plus mk squared squared. Okay. And then yeah, so here, so this is the remainder for each n, right? And also there's a remainder for this guy, right? For the ones in one. So wait. So how do I calculate the remainder in one then? So this one is the remainder in a single so the remainder in one so what we have is we are having so I should use an index for this one. So first, we know that it start at, so the ones are exactly missing the k's. So I'm also using an index from 1 to infinity of, so let's say the n should start at, oh, okay, so let's use 0 here. And so n should start at, should I start with 1 or start with 0? Let's start with 0 here. This n is equal to ik plus 1 to I plus 1k minus 1 and for the remainder, and for the rest terms, and then the sum, I will be summing over the yeah, so something a little bit bad here. K minus 1 and for each of the summand, what should I? So the summand, so initially for each n, the summand is exactly So I think the m should start I plus 1 because for each I, right? So you're basically, I know that this m basically is start n over k, the integer part plus 1, right? And then this integer part is, we are going to divide by k, is exactly I, so it will be I plus 1 to infinity. Yes, and then we have n squared minus k squared m squared over 4 times n squared a2 squared. Yeah, let's put the a2 out. A2 times n squared plus k squared m squared. So now, so here, so this is for a fixed m, right? So when we sum over the m, so m from 1 to infinity, so this is the remainder in 2. So so this looks a little bit yeah. Yeah, so let's try to write them out on the graph to see what is there any connection that we can find. So so first, let's start with 1m here. So when m equal to 1, so what we get here is that so when m equal to 1, so we will have the summation I from 1 to infinity of summation n from so when m equal to 1, so this is exactly ik plus 1 plus I times k minus 1. So 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 let's see. So for example, if you have, let's say, k here, and then it start at it will omit the k, and then it will take k plus 1. Right? Yes. It will take k plus 1, and then all the way until you have the next k, you will omit that, take points previously, and then take the points here, and then all the way continue. So let's look at the case where m equal to 2. So when m equal to 2, these start at so this n start at 1 plus I times k plus 1, and also the upper bound is 2 plus I, right? K minus 1. So so it starts at I equal to 1. Oh, wait. It starts at 2k plus 1. Okay. So it starts at this point. Right, so it starts here. And then okay. And then same pattern. So let me draw a few more in case I don't lose track of what's going on here. So let me use the like the this triangle to denote that it starts here. And then I think for m equal to 3, it starts here. So basically, yeah. So you increase 1 by m. So you increase k. So you start at this point. So I shouldn't draw this. It's a little bit ambiguous. So let's draw this 1 here. So first, let's draw when I equal to 0. So I equal to 0, what we have is so we have exactly the sum as summation n from 1 to k minus 1, right? And also we have the summation n from 1 to infinity. So these are exactly So these are exactly m equal to 2. So for each n, I know that the m will like continue like going on. And then this n star at k equal to 1, right? Oh, sorry, this n star at 1. So, and then it ends at k minus 1. So all the points in this region, I think they are being mapped by this one. Yes. And then let's see when I equal to 1. So when I equal to 1, this n star at k plus 1, and n at 2k minus 1, and then this m star at 2. So namely, so this n star at here, okay, this n star at k plus 1, which is here, and m star at 2, yes. Okay. And then n ends at 2k minus 1, right? So and similarly, for any I, the n, so it's n I star at 1, so it start at this one, and when I equal to 2, then this n must be start at this guy. Okay. And then this m will start at one more, right? Yes. So yes. So eventually, I think so all the lines that are other than like the k, they are all being mapped in, right? But let's see. So let's count the so will this converge? So let's use this. Let's use this k barrier. So yeah, I need to be a little bit careful not to include the So I don't think this k barrier is a good idea here because this line, I think they are hard to encounter, right? think it is not. I think it is solvable because. So namely, I think so. Basically, you can just delete the case row and then move everything like to the left. And in that way, I think you can have a really nice enumeration of the indexing. So yeah, but I need to be a little bit careful about the enumeration here. So so do I have time? Okay, I think I don't have time right now. So I'll try to continue the analysis next time.